Ever wondered how a database management system, or DBMS, works? Well, let's embark on a journey to understand it. A database management system is essentially a software application that interacts with the user, other applications, and the database itself to capture and analyze data. It's like the unsung hero of the digital world, tirelessly managing, retrieving, and storing data. So why is a DBMS so important? Imagine you're a librarian, but instead of a few thousand books, you have millions or even billions. It would be impossible to keep track of all that information without a system in place. That's where a DBMS comes in. It not only keeps your data organized, but also ensures it's easily accessible, secure, and reliable. In a world that's increasingly data-driven, the role of a DBMS is more crucial than ever. It's the backbone that supports our digital infrastructure, from social media platforms to banking systems. Now that we know what a DBMS is, it's time to delve into its architecture. So, what makes up the heart and soul of a DBMS? Its architecture. At its core, the architecture of a database management system, or DBMS, is the design that governs how data is stored, processed, and accessed within the system. Think of it like the blueprint of a house, showing where each room is, how they connect, and what purpose they serve. In a similar vein, the DBMS architecture outlines how different components interact to manage data effectively. Now let's break it down further. The DBMS architecture is typically divided into three levels: the internal level, the conceptual level, and the external level. Each of these levels plays a unique role in how data is handled within the system, and together they form the backbone of any DBMS. Firstly, the internal level, also known as the physical level, is where the physical storage of data happens. This level deals with the complex details of how data is stored in the storage medium, for instance, data storage in hard disks or SSDs. It's like the basement of our house analogy, where all the foundational and structural elements are located. Next up is the conceptual level, or the logical level. This level is all about how data is logically organized and structured, irrespective of its physical storage. It includes details about data types, relationships, constraints, and so forth. Using our house analogy, this would be the layout of the rooms, the function they serve, and how they are interconnected. Finally, we have the external level, also known as the view level. This level is concerned with how data is viewed and accessed by end users. It's like the decor and furnishings in our house analogy that provide a comfortable and usable environment for the inhabitants. These three levels, the internal, conceptual, and external, form the triad that makes up the DBMS architecture. Each level has its own responsibilities, and they all interact and depend on each other to function effectively. These three levels work together to ensure smooth database operations. Starting from the core, the internal level is the lowest level of DBMS architecture. Imagine the internal level as the backstage crew in a theater production. It's not typically seen by the audience, but it's crucial for the show's performance. This level is where all the data is physically stored, and it involves complex, low-level data structures in detail. Now, you might be wondering, what does it mean to say low-level data structures? Well, these are the intricate structures within the system that hold the data. They're like the scaffolding that supports a building or the foundation that holds up a house. Without them, the entire system would collapse. This level is not just about storing data, but also about how it's stored. It deals with the physical storage of the data on the hardware, making it a critical component of the DBMS architecture. This is where things get a bit complicated. The internal level provides a physical storage abstraction. This means that it hides the complexity of physical storage from higher levels of the architecture. It's like a magician performing a trick. You see the result, but you don't see the complex maneuvers happening behind the scenes. Why is this important? Because it allows the higher levels to focus on other tasks, like managing the data and interacting with users, without getting bogged down by the nitty-gritty details of physical storage. But let's not forget, the internal level is not just about making things easier for the higher levels. It also plays a crucial role in optimizing data storage. It uses techniques like indexing and hashing to make data retrieval faster and more efficient. So, while the internal level may seem complex and intimidating, it's a vital part of the DBMS architecture. It's the unsung hero that works behind the scenes, ensuring that your data is stored efficiently and safely. In essence, the internal level is all about how data is stored. It's the backbone of the DBMS architecture, supporting and optimizing the system from the ground up. Moving a step higher, we arrive at the conceptual level. The conceptual level, or the logical level, as it is often referred to, is where things start to get a bit more abstract. This level provides a bird's eye view of the entire database, painting a coherent picture of the data as it would exist in the real world. What does this mean? Well, let's consider an example. Suppose we have a database for a library. The physical level would deal with how the data about books, authors, and borrowers are stored in memory. But the conceptual level, it sees a world where there are books that are written by authors and borrowed by library members. It presents this view without getting into the nitty-gritty of how the data is physically stored or retrieved. This abstraction is a crucial characteristic of the conceptual level. It hides the complexities of the physical level, allowing us to focus on the data's logical structure. This not only simplifies the interactions with the database, but also ensures the integrity of the data by defining rules and constraints. For instance, a rule at the conceptual level might state that every book must have an author. This rule ensures that no book can be entered into the database without an associated author, preserving the integrity of our data. But the conceptual level is not just about data integrity, it also plays a vital role in data security. By controlling how data is viewed and accessed, the conceptual level can enforce security measures. For example, it can restrict access to sensitive information, like the personal details of library members, to authorized personnel only. In essence, the conceptual level serves as a bridge, connecting the physical realities of data storage with the everyday experiences of the users. It ensures the data remains consistent, secure, and in line with the real-world context. The conceptual level shapes the way we perceive data. It takes the raw, physical data and transforms it into something meaningful, something we can understand and interact with. And in doing so, it allows us to tap into the true potential of our database. Finally, at the top of the architecture, we have the external level. This level is the one that interacts with the end users. It's like the friendly face of the database, designed to make interaction straightforward and, dare we say, even pleasant. The external level provides a user-friendly view of the database, presenting it in a way that's easy to understand and navigate. Imagine you're at a fancy restaurant. You don't need to know how the chef is preparing your meal in the kitchen, right? You just want to enjoy the dish served to you. That's what the external level does. It serves you the data you need, prepared and presented in a way that you can easily consume. But there's more to it than just simplicity. The external level also hides the complexities of the other two levels, the internal and conceptual levels. It's like a mask that shields users from the intricate technical details of how the database is stored and organized. This way, users can focus on their tasks without getting bogged down by technicalities. Another interesting aspect of the external level is that it allows different views for different users. Think of it as a multifaceted diamond. Each facet offers a unique perspective, a different shine. Similarly, the external level can present different views of the same database to different users depending on their needs and permissions. For instance, a sales executive might see customer contact details and purchase history, while a product manager might see inventory levels and supplier information. They're both looking at the same database, but the external level serves them the view that's most relevant to their roles. In essence, the external level plays a crucial role in making databases accessible and useful to end users. It provides a user-friendly interface, hides complexities, and offers tailored views, all while maintaining the integrity and security of the data. The external level is the face of the DBMS, the level that users interact with. It's like the welcoming host at the front door, guiding users to the information they need and making their database experience a breeze. So, we've journeyed through the intricate layers of DBMS architecture. In the course of this exploration, we've delved deep into the heart of the database management system, unearthing its three primary levels: internal, conceptual, and external. The internal level, the core of the system, handles the physical storage of data, ensuring efficient data management. Moving outwards, we encountered the conceptual level, the intermediary that maps out the logical structure of the database, providing a unified view of data. Lastly, we stepped into the user-friendly realm of the external level, where customized views of the database are presented, catering to the needs of different users. Each level plays a pivotal role, working in harmony to create a robust and efficient system. Understanding the DBMS architecture is fundamental in managing and utilizing databases effectively. And now, you are more equipped in your journey in the realm of computer science.